In this video, I want to show that this infinite series with the expression 12 dividing by 36n squared minus 12n minus 35, that this infinite series converges to 16 over 55. And so here's the infinite series. So first we need to decompose the expression 12 over 36n squared minus 12n minus 35. So when the equivalent expression is 12 over 36x squared minus 12x minus 35. So the factors are 6x minus 7, 6x plus 5. And then using what's called partial fraction decomposition, we can rewrite this as some constant a over 6x minus 7 plus some constant b over 6x plus 5. To combine these two expressions, we can cross multiply, so we get a times 6x plus 5 plus b times 6x minus 7, and then dividing by the product of 6x minus 7 and 6x plus 5. From here we can see that 12 is equal to a times 6x plus 5 plus b times 6x minus 7. So this equation right here is true for all x. So we want to pick something that would make this factor 0 and make this factor 0. So for example, we can let x be 7 or 6. With x is 7, 6, then 6 times 7, 6 minus 7 will be 0. And so in the place of x, we have 7 sixths, and then 7 sixths. This part right here will be 0, and then this part here we get 12, so we get 12 is equal to 12a, or a is equal to 1. And now let's pick, let x be negative 5, 6. So in the place of x, we have negative 5, 6, negative 5, 6. This part will be 0. And then from here, we'll get negative 12. So we have 12 is equal to negative 12b. So b is negative 1. So now we can rewrite the expression 12 over 36x squared minus 12x minus 35 as 1 over 6x minus 7, since 8 is 1, and then plus negative 1 over 6x plus 5, since b is negative 1. So here's our original series. So now we can rewrite this as the series with the expression 1 over 6n minus 7 minus 1 over 6n plus 5. And now let's form some partial sums. So this is the sum of the first 5 terms, and it's 0.22785449. This is the sum of the first 10 terms, and it's 0.258575. Sum of the first 100 terms is 0.287586. Sum of the first 1,000 terms is 0.290575. Sum of the first 5,000 terms is 0.290842. Sum of the first 10,000 terms is 0.290875. And then sum of the first 100,000 terms is 0.290905. So these are called partial sums. And now let's write the sum of the first k terms. And here's our infinite series again with the expression 1 over 6n minus 7 minus 1 over 6n plus 5. So let's generate the first 15 terms. So here's the first 15 terms, and then this is the kth term. So in the place of n, we just have k. So once again, right here, to form this kth term, then in the place of n, we just replace n with k. And then the term before the kth term, replace n with k minus 1, and then simplify, and then this is what we'll get. And then the term before it, this term, replace n with k minus 2, and then simplify. Replace n with k minus 3, replace n with k minus 4, replace n with k minus 5, and so on. And then now we can see that the terms we can that will get cancelled. So we see that this minus 1 over 17 and 1 over 17 they'll get cancelled. And then minus 123 and 123, and 129, 129, 135, 130 over 35. And so we can see that eventually all of these terms will get cancelled, and they will drop out. And so what's left is just the 1/5 and the 1/11. And then down here we can see that the 1 over 6k minus 13 and 1 over 6k minus 13, 1 over 6k minus 25, 1 over 6k minus 19, 1 over 6k minus 7, and then the 1 over 6k minus 37, 1 over 6k minus 31. So eventually all of these terms here, they also will drop out and they will get cancelled. And so for the kth term, what's left is 1/5, 1/11, minus 1 over 6k minus 1, and minus 1 over 6k plus 5. So once again, this is our original infinite series, which is the limit of s of k as k approaches infinity. But s of k is 1/5 plus 1/11 minus 1 over 6k minus 1 minus 1 over 6k plus 5. And as k approaches infinity, this term here approaches 0, this term approaches 0, so we end up with 16 over 55. So we say that this infinite series converges to 16 over 55. And that's the end of the video.